This video is for Algebra Homework from Tuesday, December 5th, 2017, and it was factoring trinomials with a leading coefficient of 1. So on number 1, you were supposed to match each trinomial to its correct factorization, and this just has all the different setups with the combinations of signs. No matter which one it is, we remember that the end number comes from a product and the middle number comes from a sum or sometimes a difference. What we're really trying to do is use those product and sum charts to go back and see which two binomials would have been multiplied by each other to give us these trinomials. So the first one, I've got two numbers that multiply to give me a negative 10, so they have opposite signs, but together, when I add them together, they're going to give me a positive 3. So I need a positive negative, and I see that I have that here with C. Negative 2 times a positive 5 will give me a negative 10, and a negative 2 plus 5 will give me a positive 3, so that is C. Now I'm looking for two numbers to multiply to give me positive 10, but add together to give me negative 7. So negative 2 times negative 5 will give me the positive 10, and negative 2 plus negative 5 will give me negative 7, so that is B. On number 3, two numbers that multiply to give me negative 10 but add to give me negative 9 are going to be negative 10 and positive 1. And so that means that D must be the answer to number 4. The two numbers that multiply to give me positive 10 are positive 10 and positive 1, and they also add to give me positive 11. Factor completely. This one you are going backwards, and I know that B times B gave me B squared. So I'm looking for two numbers that multiply to give me 56 but add to give me negative 15. So this tells me my signs are going to match, and this tells me they're both going to be negative. So I'm thinking of the factors of 56, and right off the bat I'm thinking 7 times 8. And I know that if I add 7 and 8 together, they give me 15, but in order to give me negative 15, they must have both been negative. Now you could have also written it as b minus 8 times b minus 7. It doesn't matter the order. What matters is that they have the right signs in front of them. So the answer to number 3, following the same rules here, I've got n times n. This is a negative number, so the signs had to be different. Factors of 45, that will add up to give me a negative 12. So I'm thinking that they have to be opposite, so it's probably 3 times 15, with the 15 being the negative, because a negative 15 plus 3 will give me a negative 12. So the 15 is the one with the minus, and the 3 is the one with the plus. Number 4 is a little bit different. Now I'm asking you what number would B have to be in order to make this a factorable trinomial. So you're considering the possibilities. So you know the end is negative 20, so you're thinking of two opposite signs, the factors of 20. You've got 2 and 10, with the 2 being negative or the 10 being negative. Then you've got obviously 1 and 20, switching the negative with those. You've got 5 and 4, trying the negative with both of those. So if it was negative 2 and 10, that would leave me with a positive 8. That's not an option. 2 and negative 10 would leave me with a negative 8 if I added it. That's not an option. Then I've got negative 1 and positive 20, which gives me a positive 19. The next one, if I added them, would give me a negative 19. The next one, negative 5 plus 4, would give me a negative 1, and 5 plus negative 4 would give me a positive 1. So the only one out of these options that are on my list is the positive 19. So if it was a positive 19, it would be factorable. Alright, so this one we are factoring. Before we factor, we gave you a hint. Look for your GCF first. I see that I can take out a 5m from the entire thing. And when I divide each term by this GCF to see what's left, I have m squared plus 6m minus 7. Now I need to make sure that this inside piece cannot be factored further, so I'm going to try and break that down into two binomials. So this must have been m and m. Factors of 7 is prime, so it's 7 and 1. It's negative, so the signs had to be opposite. The 6 is positive, therefore the 7 must be the positive, because I'm going to have a plus 7m minus 1m, which will leave me with a positive 6. Okay, so this is our final answer. I have to make sure I keep the 5 in with it because it is part of the answer. All right, question 6. The area of best rectangular garden is this trinomial, square feet, and the width is x plus 6. So this is a trinomial, and they're basically just giving us one of the factors. So I know x plus 6 is one of the factors, so the other factor has to be x plus 7, because 7 times 6 gives us 42, and 7 plus 6 gives us this positive 13. So that is going to be the length, because to get an area, you've got a length and a width, and they already told us the width. We just found the length. I'm going to go ahead and put in x plus 7 in parentheses there. The perimeter in terms of x, meaning that we can't actually get a number, means that I have to find the perimeter. Now I have the width and I have the length. I know that I could just add all four up, or I could double each and then add them together, because the width is going to happen twice, the length is going to happen twice. So I have, if I double each of them, if I times the width by 2 and the length by 2, I've got 2x plus 12 and 2x plus 14. And I need to add them together because I'm adding all four sides. That leaves me with 4x plus 26. So I didn't multiply anything by each other to get perimeter. I just added the side lengths up. So the answer should be 4x plus 26. Okay, the last one is the bonus. So it was a two-part bonus. In order to do this one, I'm going to follow the same rules. First of all, I don't see any GCF, so I can't pull anything out. Generally, that front leading term has been like a y squared, and so it would just come from y times y, but now it's a y to the fourth power, so it must have come from y squared times y squared, because we know we add the exponents when we multiply, and 2 and 2 would give us 4. I know that my n term's negative, so I've got to have some opposite signs here. Factors of 24 that would give me technically a difference of 5 here, because there are different signs. It's going to be 8 and 3. Well, the 5 is negative, so the 8 must be the negative, because a negative 8y squared plus 3y squared is what's going to give me a negative 5y squared. Now the second one is the one that's really tricky. At first you kind of want to pull something out, or you're tempted to FOIL this. What you need to do is think of these binomials like we would just a variable. Like if this had been x squared minus 4x minus 45, I would have factored it, saying this was x times x. The factors of 45 are 9 and 5. That will give me a difference of negative 4 here. So I know 9 times 5, the 9 has to be the negative, and the x has to be the positive. So that's just if there were x's in places of these binomials. Well, that's not the case. I'm going to now, this is the answer, but instead of x's, I've got m minus n minus 9 times m minus n plus 5. Because if I were to FOIL this back out, this is what it would give me. It would give me like a minus 9 times m minus n plus 5 m minus n, which leaves us with a minus 4 m minus n, and then the negative 9 plus 5 gives me negative 45 at the end. M minus n times itself is what gives us that leading term. So that was a little bit of a trick, but this should technically be the final answer. Okay, so I hope that helped. If you have any further questions, you are welcome to come ask.